Hi everyone. In the given problem statement, we are going to construct a binary tree from Inorder and Postorder Traversal. If you have already gone through my previous problem where I have solved constructing a binary tree from pre-order and in-order traversal, this problem is going to be pretty familiar. So let me write the binary tree. So we have our root node, which is 3, 9, the left child. We are going to have 20, the right one, then 15 and 7. So let me first construct the in order. So if I traverse in order basically means first we are going to do the left child, then we are going to root node and then right child. So the value would be the left child is 9, then root which is 3, then the value would be 15. Here we're going to traverse the left child, then 20 and then 7. The post order would be first we are going to do the left child, then right child, and at last we are going to do the root. So here, right, the value would be first 9, then we are going to do again, we are going to come to the 15, then 7, which is the right child, then we are going to do the 20th, the root of this, and at last the 3, the main root. So this would be the idea. Now here, are you able to find some similarity? Unlike the pre-order where root was at the first, right, here the root is at last, and this is where we have to construct it. So if I write the algorithm, let's say def build tree, our value would be in and pre. The first thing that I'm going to check is if not there are no in order value, in that case return none. In all the other cases, I would be going to do root equal to tree node. And here, right, in the previous one, we are taking the pre-order first value, we are going to take the last value. So one way of doing it is pretty familiar, which is that if I pop the element out, so it would be, instead of pre, it would be post order dot pop the last element 3, right, is going to get popped out, and our main, right, first element of the tree node is going to get created. Now I'm going to get the mid value. So mid equal to in order dot index. Here to get it, like I can do root dot val. So here, right, what would be mid value? Here it would be the 1. So 1 would be the mid value out here. Let's say mid equal to 1 for now. Now I have to construct the left child and right child. First I have to do the, let me do the root dot right. Here I have to do right child first. Equal to, I'm going to call this function build tree. And here I'm going to pass the in order value in, which is going to be mid plus 1 to all the elements. So in order, right, all this element is going to the right child 15, 20 and 7. And the post order, because we are popping the element out, right, so we don't have to do anything in post order. The post order value would be 9, 15, 7 and 20. So I just can say post. Pretty straightforward. Then root dot left is going to be build tree, and in order value would be any value before the mid. So all the values till the mid. So 9 would be on the left here. So 9 is on the left child and 1527 is on the right. And again the POS. So here, right, once I'm getting the 9, let's say left is getting called, I'm going to get 9, and from 9, right, I'm going to create the value which is just the 9, and 9 got created, and at last we're going to return root. Now for the right hand side, right, again 15, 20 and 7 is there, and 9, 15, 7, 20. So 20 is going to be the last element, so you're going to pop it out, find the mid. So here, right, mid would be the first index of it, because here, right, only the values which are present, right, 15, 20, 7, and here the post order the values are 9, 15, 7, 20. So mid is 1. So here, right, any values to the left is going to be on the left child, anything is on the right child. So 20 is going to be the root, so I can say 20 got the root value. Here I can see, right, I'm forming the root. So 20 got the root value, and what would the left child? Left would be the value of 15, and the right will have the value of 7. So anything from here, right, you can easily devise the formulation. So that would be pretty basic structure. And right here, the time complexity would be big O of n square, but there is also a linear time solution available, which would be a bit more complicated. But for this sort of solution, right, big O of n square is pretty efficient too. So now let us jump for the Python solution. The first thing that we're going to do, we are going to check if the value of Inorder is present or not. So if not, Inorder, then you're going to return none. Else the root is going to get formed by, we are calling the function tree node, and we are going to pop the last element of post order dot pop. Once that is done, we are going to find the mid. So mid is going to be in order dot index root dot val, and then root dot right equal to calling the function, so self dot build tree in order mid plus 1, and then post order. Similarly, root dot left is going to be self dot build tree in order. All the values from the beginning till the mid is going to be on the left side, and post order. In post order, just passing the value as it is, because you are already popping out the elements, so no need to do anything more. And we're going to return the root. I hope there are no spelling errors. And let me run the code. Let's see how it works out. Yeah, as I assumed, it would be tree node, not tree none. So let me run it back again. As you could see, the test case got passed successfully. Let me submit it up. And the code submission is successful, and it is beating 54.11% submission, because it's big O of n square. There is a linear time solution available, but which would be much more complicated. And for most of the time, this solution would suffice. That's all for this video. See you in the next one.